This is Inchara from Sri Venkateswara College of Engineering under the Department of Computer Science and Engineering in Cyber Security. Today we will explore the fascinating world of vectors and how they relate to volume. But first, let's start with a simple question. Have you ever wondered what makes a vector different from a scalar? In essence, a vector has both magnitude and direction, while a scalar only has magnitude. This seemingly small difference is what makes vector volume such a powerful concept in mathematics. Now imagine you are standing at the edge of a cliff, looking out at a beautiful landscape. You see a river flowing through the valley and you wonder how much water is in it. This is where vector volume comes in handy. By using vectors to represent the flow of river, we can calculate the volume of water that passes through it in a given amount of time. Pretty cool, right? And this is just one example of how vector volume can be applied in real world situations. Vector volume is a mathematical concept that refers to the amount of space that is enclosed by a set of vectors. Usually scalar volume, which only takes into account the magnitude of an object. Vector volume also considers its direction and orientation. To illustrate this concept, imagine a cube with sides of length a. The scalar volume of this cube would be A, since it has a width, height and depth of 1 unit each. However, the vector volume of this cube would be square root of 3, since three vectors that define its edges have the length of square root of 2 and are oriented at right angles to each other. Vector operations are fundamental to understanding vector volume. Vector addition is used to combine two or more vectors into a single vector. Scalar multiplication, on the other hand, involves multiplying a vector by a scalar quantity, such as a number. Both of these operations are essential for calculating vector volume. Vector addition is particularly important when dealing with multiple vectors that combine to the same volume. By adding these vectors together, we can determine the total volume of the space they occupy. Scalar multiplication, on the other hand, allows us to scale a vector up or down in size, which can be useful for calculating volumes of irregular shapes. Properties of vector volume. Vector volume has several important properties that make it useful in mathematical calculations. One of these properties is linearity, which means that if you multiply a vector by a scalar, the resulting will be parallel to the original vector and has a magnitude equal to the product of the scalar and magnitude of the original vector. Another important property of vector volume is additivity, which means that the volume of the sum of two vectors is equal to sum of their individual volumes. Finally, homogeneity is another property of vector volume, which means that if you multiply all the components of a vector by the same scalar, the resulting vector will be a volume that is equal to the product of the scalar and its original volume. Challenges and limitations. While vector volume is a powerful tool for calculating volumes in three-dimensional, there are some challenges and limitations to its use in mathematical calculations. One of the main challenges in vector volume can only be calculated for closed surface, which limits its applicability to certain types of problems. Additionally, the calculation of vector volume can be quite complex, especially in cases where the surface is irregular or has a complicated shape. Another limitation of vector volume is that it is not always easy to visualize, unlike scalar volume, which can be represented as a single number. Vector volume requires more abstract understanding of mathematical concepts such as dot products and cross products. This can make it difficult for students and researchers who are new to the field to fully grasp the concept and apply it effectively. Conclusion, vector volume is an important concept in mathematics and has numerous real-world applications. We have discussed how to define vector volume, the properties of vector volume, and its limitations. Understanding vector volume is crucial for anyone interested in fields such as physics, engineering, and mathematics. By mastering this concept, you will be able to solve complex problems and make significant contributions to these fields. Thank you.